from Westcliff, Colorado, which is one of the most beautiful little communities I've ever been in. And he's now moving into the Dome, so that sounds like a really neat project. He's been speaking at these conferences now for a few years. He started studying what he calls weird science in college at the age of 12, and about 6 to 7 years ago he started actually applying what he'd been studying. He's been branching into every field, including alchemy and linguistics. He says he has a little bit about linguistics for us today, and then he has a vision for the future to make this world a great place for all the children and everybody coming up. And I think that's pretty neat because I share that vision.
Said, but that's okay.
He also has invented a chair for Sage's little sister. Sage is here with us too, and she's his daughter. And you can wave if you want. And her little sister has cerebral palsy, so he's finding that some of this stuff has very direct application in his family. So here's Vernon Roth.
Well, this conference is turning out to be really neat and really interesting. So we're going to move. We've got a lot of information to cover and talk about. If anybody has any questions, just shout it out, and anything, if I move too fast, just ask any questions you need to, and I'll try and cover it as quickly as possible, but we have a lot to go over. So this year has been very, very interesting, and in the research aspect and everything that my family and the people that I've been working with have been discovering. I've been back and forth across the country. I have been north and south, back and forth, and seen many, many amazing things and experienced many amazing things. So we're going to be talking a lot about that today. So, oh, there's a laser. Wonderful. All right. So to start out, the left button. Okay. To start out, we have a little quote here. And I want people to be thinking about certain things as we go into this presentation today. This is a quote from 100 years ago, and it's absolutely applicable at this point in time. It says, "Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality." So what this means is that you can create formulations all day long that says this is the nature of reality or that is the nature of reality. But none of it actually stands up, none of it actually works until you apply it to our physical reality. Now this isn't just a weird science phenomenon. Because I was actually studying a mechanical motions book, and in the very, very first preface, it shows it postulates a problem to you. And this is a problem of two pulleys, two ropes, and a weight. And so the weights say to the pulleys, it says, "I want to move, I want to go someplace." And so they get their two ropes involved, and they loop themselves up and over the pulleys, and they want to try and figure out exactly how much weight is going to be on this rope and how much weight is going to be on this rope if the two pulleys are offset and of different sizes and such. And in conventional science, there is no formula to calculate this out. There is no way to theoretically figure out how much weight is going to be where. It has to be done experimentally. And this is conventional science saying, yes, we can't figure out a simple mechanical motion. We have to actually do it in physical reality. So I want you to remember that as we go along here today, and as we examine the future, as we examine these technologies, because you actually have to get down and do it. There's all these all these equations that say energy cannot be pulled from magnets. But as you're going to be seeing today, energy can be pulled from magnets. And it's not new. It's been around for 50, 60, 70, 100 years. It's been dreamed of for thousands of years. So maybe they had it too. We will see as we move on. That, by the way, was Nikola Tesla. And he was using it, like I said, 100 years ago, and it's just as applicable today. And we're not moving anywhere. Where's the device I'm controlling here? Oh, there we go. Okay, last year I said some things that should have thrown off a lot of red flags. And first of all, one of those things was talking about the crystalline structure of a material. Crystalline structure dictates whether or not a material is going to be a magnetic, paramagnetic, diamagnetic. Does it have conductivity? Is it superconductive? Is it semiconductive? Does it deflect magnetism? Does it absorb magnetism? Does it transmit electricity? Does it absorb radiation? Does it negate radiation? All of these things can be done with conventional materials, but it is entirely dependent upon the crystalline geometrical structure of the material. So, if you want to, do you think that would be an applicable thing to a magnetic motor? There are materials that deflect magnets, magnets, but deflect magnetism at a 90-degree angle. There are materials that absorb magnetism. You put that over a 10,000 Gauss magnetic field, you'll have zip on the other side. It's kind of dangerous, and we'll get into that, but that's okay. There's also materials that of course they emit radiation, but there's also materials that negate radiation. It all has to do with the crystalline geometrical structure of the material. So what we're going to do is we're going to examine that. Now, think about that as we're going in today, and we're going to talk about a little bit about ether and how this applies to magnetism and how this applies to energy. So first off, how many people believe that ether or one of its various incarnations exists? Raise your hand. Okay. Everybody here, just about everybody here believes that ether or one of its various incarnations exists. Yes, absolutely. There it is. If we need a magic marker, we'll just put a little A in front of that E and we'll be fine, right? Oops, wrong way. Okay. The reason why it's been very, very difficult to prove with conventional science the existence of ether is because it's very difficult to find a differential in the ether. We're going to get into that. But let's imagine that if you were a fish living at the bottom of the ocean, swimming along in the water, philosophical question says, is the fish even aware of the water, or is it just the medium that it is used to moving through? Okay? So we are the fish at the bottom of the intergalactic fishbowl, moving through a substance, and we've been talking about it, etheric gas, the various different incarnations or labels that we like to put on things, because as human beings we have a very difficult time with anything we can't quantify, qualify, and easily cross-reference. So, we're going to talk a little bit about differentials because it is absolutely essential to finding ether and experiencing ether and utilizing ether. First of all, we're going to talk about conventional differentials. Wind. If I'm standing here, stationary, and the wind is blowing past me at 60 miles an hour, there's a differential there. And I can have power. I can find power because there's a differential from my position as stationary and the 60 mile per hour wind that's going past. If I'm running at 60 miles an hour, then there's really no differential between me and the wind. I can't get energy from that spot. Water, flowing water. You have a stationary object, you have water flowing across it, you have a differential, and that is the way you gather energy. Temperature. Until recently, it's been very difficult to get power from a temperature differential. With the development of better and better thermocouples, better and better, for instance, Peltier junctions, this is becoming more and more applicable. I just recently saw pictures of a house in Tokyo, Japan. It's 5 stories tall. It runs entirely upon its own power, and that is done all with temperature differentials, super efficient thermocouples that allow amazing power from very, very slight temperature degree changes. So at night you have temperature, you have a higher excuse me, higher temperature inside and a lower temperature outside, you have a temperature differential, and vice versa during the day, and this thing generates its own power in the neighborhood of 30 kilowatts. So, sunlight, of course, is another differential. We have light coming at us. Over here we have no light, we have a differential, we can get power there. And of course, there is the electrical circuits. We'll talk about that a little bit later. Now, the unconventional differentials are magnetism. Magnetism, we have an automatic differential. We have north, we have south. We'll get into more about that because that's actually a fallacy. We just like to call it those. But that is a differential, and we can get power from that. Etheric accumulators. If you have a certain amount of etheric energy out here, and you have a very powerful etheric energy here, you have a differential, and you can create power there. Certain shapes and patterns, documented by Dan Davidson, will create differentials as well, and their three-dimensional equivalents are wonderful little geometrical patterns here. Those all create differentials of etheric energy, and if we learn how to tie into those, we can have as much power as we want. Incidentally, this is also how we experience our physical world, okay? You cannot experience the world without a differential. If I am the fish in the ocean and it is completely black, I can't see anything. There must be shades. If it's completely light, I can't see anything either. There has to be shades. This is how we differentiate our physical reality. My hand is moving through the air and suddenly it hits something, the differential tells me that it's there. This is how we measure magnetism, how we measure light, how we measure electricity. So think about these things. When you start to look at it this way, you start to realize that there is free energy all around us. So, moving right along. We're going to talk about etheric light, and which is my favorite label to put on ether energy. And we're going to be talking about geometrical structures. When I talked last year, I said that everything comes down to geometrical patterns. What type of geometrical pattern is in the crystalline structure of the material? And so we have these beautiful geometrical patterns. All of the gold ones up here are the platonic solids. Plato said that all nature, all materials are divided up into different geometrical patterns at their center, at their core. And we found that this is absolutely true. This, by the way, is the geometrical pattern of gold. And I'll show a picture of it later on. But this is also the geometrical pattern esoterically that would say life, rejuvenation, and all that fun stuff. Later on, the geometrical patterns become the Archimedean solids, which are the platonic solids melded into other shapes and forms. And how you put these forms together dictates what you have. Oh, I forgot to mention it. I'm not just talking off my hat here, okay? There are three genius guys who woke up one day and said, hey, I want to know why this material, this little piece of steel or this little piece of copper will conduct electricity versus that cloth or that piece of plastic will not. And so they set about figuring this whole thing out, and eventually they got the Nobel Prize for this research because they were able to make plastic that is able to conduct electricity many, many times better than metals. You can conduct electricity without a magnetic field. How's that? That's interesting. And they did it all by structuring the material with crystalline forms. Got the Nobel Prize for it. They deserved it. It's fantastic research. So this is actually being backed up by conventional scientific research. All right, so, excuse me. When we start to infuse etheric energy into different crystalline geometrical patterns, we get different types of energy out of it. All right? When etheric energy is imploded, well, I'm getting ahead of myself there, sorry. When you structure the geometrical the energy into patterns, you get different types of energy out of it. All energy is born out of the ether. This was said 100 years ago. It's being said now in conventional physics. They just say it a different way. Light, magnetism, everything is born out of the ether. Without it, we don't exist. If you were to remove all of the energy from any given location, all life in there ceases to exist, which is actually documented by people that have removed all magnetism from certain areas and everything in it dies. So we're going to move right along here very quickly. And we're going to say, what is the mechanism that allows ether to become energy? And that mechanism is implosion. The mechanism is implosion, and that is what allows us to take ether and condense it down into either energy or physical reality or all of the various incarnations between, because not everything is completely physical or completely etheric or energetic. There are various stages in between. There's another one. So what is implosion? Etheric implosion is an etheric implosion is an internal repeating pattern that when it encounters itself, it generates an external field. So, if we have a pattern right here, and we were to charge this with etheric energy, it would be there, it'd be cool. I mean, on a subatomic level, whatever level it is, it's charged with etheric energy. As soon as it meets itself, then it generates an external field. How it meets itself dictates what types of external fields it generates. So, to say that another way, etheric light implodes into a geometrical shape, creating a self-repeating fractal. This is what we measure as all the various incarnations of energy. So, if you ram enough etheric energy into a single location, and it's a single geometrical pattern, there's a button right there, and it's a single geometrical pattern, what do you get? You get a radioactive material. We've done it. Turned a steel rod using nothing but an etheric imploder into a highly charged alpha source. You can make it go away. It's a little bit more difficult to make it go away, but this is what happens. What's that? Oh, okay. So when you are able to charge the energy, into a crystalline pattern, you get different things. This is what happens in conventional magnetism. We have a coil. We put in our little pieces of neodymium that isn't charged yet. We pound a whole bunch of joules of energy into it, and boom, you've got yourself a magnet. What are the strongest magnets now are up to 83 pounds per square inch, something like that. I don't remember exactly what it is. We pulled straight across. With this technique, with this understanding, we've actually done in the lab, we've actually gotten not neodymium, not these rare earth exotic materials, we've gotten pure steel up to 87 pounds per square inch. So, and the interesting thing is, if you were to take two neodymium magnets, like these right here, you take two neodymium magnets and start to heat them up, they're going to lose their magnetism very, very quickly. That steel is going to hold its magnetism until it's melting apart. So, the applications for that are tremendous. Anybody seeing applications for that? Okay. I like audience participation. If I make sense, tell me. If I don't make sense, throw something.
Curie's law is no longer valid in that situation.
Listen, one thing that he said, Curie's law is no longer valid in that situation. Here's the deal. When I went into physics, studying physics with Professor Gilbert, he just passed away recently, he said something interesting. He said, there is no law. There is no real law. This is all a story. This is all a creation of people that have decided that this works for right here. Okay? But what about right over there? Does it work over there? Does it work over there? If you don't like the story, go out and write your own. Do it all over again. Whatever. These are what I'm going to be talking about today. These are techniques that you can use to explore the reality, but reality isn't a law. Reality is an amazing, changing, and dynamic force. So laws, you know what? They work in one way, they don't work in another way. We worked with Newtonian physics, then we went to Einsteinian physics. Well, in the interim, we went to ether physics, and now we're going to quantum physics and wave theory and all these different theories. Don't get stuck in a law. If you don't like it, rewrite it. That's what it's for, right? That's what the laws of a country are for. You don't like it? Okay, we'll change it. We'll figure it out. Okay, I skipped over this. Oops. Can we go back real quick? Thank you. I skipped over the gold structure of the cubic gold structure, which is very interesting because there are several other elements that are also cubes, and they are just lacking an essential holographic possibility of an atom in the center, or excuse me, not an atom, but an electron in the center. And if you were to infuse those other elements with enough electricity or enough energy, you would then make gold. Oh, this is actually, I'll wait until the end of that. Somebody remind me about that later, okay? Don't worry, we don't need to go back. All right, moving right along. We're going to be examining magnets. Now we've got these cool little neodymium magnets here, and one thing that I've noticed when people are working with magnetic motors, and I've seen a bunch of them, we're taught that magnets are these cool little static things. Now, how many people here have been taught that magnet is a static unit? It has a set field. Everybody raise your hand if you've been taught that magnet is a static thing. All right, about there's half or so. That is not a reality. The beautiful little patterns that come when you put a magnet under a set of iron filings is what happens when you line up a whole bunch of microscopic magnets together and you allow them to take whatever shape you want. This is a static field. Magnets are not static at all. They are not static. They move. They are very dynamic. They flow. Okay? That's what happens when you stack up a bunch of tiny magnets together, is they take that shape. Now that's a shape that we can work with, but it's not the true nature of a magnet. It is a fake, it's not reality. So we're going to I need some audience participation. Sage, would you come up here, please? We're going to do something real quick. This is what's called a tri-field meter. It measures electromagnetic fields, magnetic fields. You see that you have to get this magnet very close to the meter in order to deflect it. I'm hoping you can see that out there. Oops, there we go. You have to get it very close to the meter in order to deflect it. And as soon as this is a little thing, I took the fan off of a little electric motor fan. You can definitely not measure, that would be great. If you could set it down right there, we could use that. The tube too, the tube. John, the tube too, please. Yeah, you notice that it's not deflecting through her body at all. But we're going to just turn on that. And suddenly, whoops. Sorry about that. There we go. Sorry, sweetie. Did everybody see that? As soon as the magnet, you can't put it back on. Okay. As soon as the magnet starts to spin, it starts to deflect. Now, how many magnetic motors have you seen that the magnets all turn on a rotating shaft or on a disc or a flywheel? And then right outside of that, they got themselves a magnetic shell, a housing, maybe some bars holding it in place. Okay? If you build a motor to work on a static magnet, and as soon as you start moving it, it's not going to do anything. Because the entire dynamic of the magnet has changed at that point. All right? Now mapping where that changes, where those changes occur, thank you, sweetie, you can sit down. Mapping where those changes occur, that's going to be a very complex task, but we have some help with that. Next thing, now everybody's seen it, but I've got to do it on film. We've got a piece of metal here that does not, there's some strange reactions when you get it close. But you drop this thing, you drop this through, and it takes a very long time to fall through because everything in the universe is either magnetic, diamagnetic, or paramagnetic. Now, before we got our beautiful little periodic table of elements, it has hydrogen over here and it goes down, and got the radioactive elements down here. Before they put that all together, there was a much more intuitive table of elements. And that started out with the magnetic materials here, the paramagnetic materials here, and the diamagnetic materials over here. And you know what connected these things? The noble gases. Connected them all. And you know what alchemical research, which is not actually labeled alchemical research, is now showing is that to change one to the other, it requires an implosion and noble gases. So, moving right along. Oh, I'll get to that later. Okay, so that was the older periodic table in use about 1920s, somewhere around there. Yes?
Can I have a piece of paper and a pen so I can write this down?
You can have all my notes after we're done.
Okay.
All right. Anyway, here we go. Oh, we just did our magnetic experiments, so we're ready to move on. Oh, I got one more for you. Anybody seen on the YouTube or anywhere they see the experiment where you put an electrolyzer into water and you're bubbling the hydrogen and oxygen off, and you put a magnet underneath it and it starts to swirl? I mean, look that up sometime. Swirling magnetic fields. It's very, very, very illuminating. So we're not draining the magnet, but it's actually causing a change in the physical reality of those hydrogen and oxygen bubbles coming off. Well, there's an interesting fellow by the name of Eckhart. I'm sorry, it slipped my mind. I believe it's Eckhart. Did some experiments. Way back when, they got hydrogen out of water by putting an iron bar into a vessel that's filled with a 10% sulfuric acid solution. And they'd get hydrogen off. This is what they used to power the street lamps with in New York. They'd get hydrogen. They filled balloons with this stuff coming off of there. So he said he wanted to see what would happen if he put a very, very powerful horseshoe magnet around this bar. And so he did this, he set it up. He actually had 2 bars set up in a glass tube, and he put a very powerful horseshoe magnet on these bars. And you know what happened? He suddenly found that he was not just getting hydrogen, he was suddenly getting oxygen as well. Now wait a minute. Here we have a completely passive device, a horseshoe magnet, generating electricity, because that's the only way you're going to get oxygen off of a bar in a situation like that, is if you've actually got an electrical current flowing back and forth. So he's got an electrical current flowing from a horseshoe magnet. So he did all sorts of experiments. He hooked up wires, completely shorted the whole system out, and it was still bubbling oxygen off of the solution. What was very interesting about this was, I mean, that's cool. We know that magnetism can generate an electrical field. We know that. But here's the real kicker, and this is the question that I want you guys to think about this and have nightmares about, and that is that the magnet died. The magnet lost 10% of its power every 24 hours. All it's doing is energizing an iron bar. It can sit there and do that for 1,000 years. But under this condition, it died. Now, why is that? Think about that as we go on. Okay. How many people want to see something that will actually help them to understand true magnetism? Could we click play on that? I think you just have to click it. Thank you. It's not working. Huh? Yeah, that's a video. Anyway, what you're about to see is an actual real-time footage of a neodymium magnet, and it's about this size, north and south.
I need your thumb drive. No, keep hanging on.
Yeah. Ow. Thank you. Thanks, sweetie. Here you go. I'll get it later. Yeah, there you go. Let's go put this over here where it's safe. All right. What we're going to be seeing here is an actual real-time footage of a magnetic field as it flows. And this is north and this is south. And we're hoping that it's actually going to work because it's really fantastic. This is a true magnetic field. This is not the iron filings that you saw stacked up on top of each other. This defies that. It's not working, is it? What's that?
Is that magnetic viewing film?
No, it's not. I cannot tell you how it's done. I'm sorry. But if you want to experiment, great, go for it. But I cannot tell you how it's done. Anyway, what you will see here is two counter-rotating vortexes of energy. They are in constant motion. They never stop. The magnets just keep on going, and every once in a while you'll see one disappear off there and another one come in from the side, and they'll just keep on flowing and keep on flowing, and they never stop. So this, my friends, is really the motor of the universe. It never ends. It keeps on going forever and ever. And so, what are those particles? Now, that's an amazing question. I'm going to tell you a little story while we're working here, and I'm hoping I don't get in trouble for this. But a friend of mine takes a very powerful big neodymium magnet, and he puts a glass suction on one side, and draws a hard vacuum on it. Puts a glass suction on the other side and draws another hard vacuum on it. Then puts the whole thing into a vacuum chamber and draws a hard vacuum on it. Right? And they X-ray spectrographed it out. There's nothing there. There's nothing inside that hard vacuum. And so they leave it, and they come back a month later, and there's still nothing there. All right, there we are. There we're going. See? This is real-time footage of the magnetic fields. They're not being stimulated by anything. Nothing external is coming in. That is the magnetic field right there. That is the reality of a magnetic field. There's a little bit more to it than this, but that's enough for right now. Now, you remember I said that everything is either diamagnetic, paramagnetic, or magnetic.
Vernon, where's the magnet?
The magnet is right down here.
Running horizontal.
Running horizontal. So the magnet is being held, right there. Okay? And it's just a little magnet. This was about an inch long magnet. So here we have this magnetic field. Now, if you've ever played with magnetism and you try and stick something to a very powerful magnet, you bring a needle in or a nail or something like that in here, it's going to automatically jump to this side, right? It's going to jump to this side. You can't stick a piece of metal, a small enough piece of metal, right here because there's no magnetic field right there. You know what will stick there? A piece of diamagnetic material, because there is a different field associated with diamagnetism than magnetism. Diamagnetics, highly unexplored, but there's a field associated with it, and it will stick at that point. You can put a sphere magnet there too, and that'll generate enough of a field that it wants to balance itself out in this nice little triangle pattern here. But anyway, this is the true nature of magnetism. This is the way it moves. Yeah, thank you, John. I really appreciate that. This is the way it moves. It continually rotates in counter-rotating fields. Now, here's the kicker. We're going to move on. This is just one set of fields in a magnet. Wait a minute. We were told we got a north and we got a south. That's it, right? Yes?
Is it always slow like that?
It moves faster for stronger magnets. The medium that we were using there kind of slowed it down so we could actually see it. So it was very, very quickly. Oh, thank you. I moved right on ahead. This is the true nature of a magnetic field, this spider web here. This is what we call north. These are what the red are what we call south, and they move all the way around. In every single magnet, there are 16 counter-rotating vortexes of energy that all have different properties involved. Literally, on the workbench, I don't know why I didn't think about this before, I just barely thought about this, as illustrates in this. We could take a piece of steel, a round piece of steel, and set it down there on the workbench and find the right interchange of magnetism, right interchange of fields right there, and we can push that interchange into that iron bar, and instead of that iron bar leaping to the magnet, it'll try and get away as fast as it can. Because different fields interact with different materials in different ways. Okay? This is the true nature of magnetism. We're just barely cutting the edge, or cutting our teeth on exploring this, because there's so many permutations and so much stuff. Some will pull into different. Some will pull into steel. Some will pull into iron. Some will repel iron. We can levitate things with the magnets now because we find the right fields and the right interactions to make it happen. So, That is the true nature of a magnetic field. All right, moving right along.
Do you have a reference for that type of levitation? Where you could
It's in my lab.
suddenly
It's in my lab. It's sitting on the shelf. We haven't published anything out. It's not public knowledge. You guys are actually hearing most of this for the very first time, except for some of the people that have been in the dinners. Okay, you're not going to find 99% of this on the lab. Wait, why are we here?
Thank you.
Okay. All right. So you've seen the fields. You've now seen them moving. You've now seen the motion that happens inside of a magnet. Can we go back to the one right before this? Thank you. You've seen these fields now. Now, what's really going on here? Let's talk a little bit about what is really going on. Oh, this, by the way, all this work is done by my friend John Depew. This artwork, it's absolutely beautiful. He's the foremost expert on the true nature of magnetic fields in the world. No one else has got it, and he's got some great stuff here. So, we're going to talk a little bit about the etheric field now. All of these points where these things cross are actually where the ether energy is tying into this reality. And so if we can create a big enough field out here, we can superimpose whatever's going on in there on something outside. So, with that in mind, how many of you guys want to see an actual over-unity device? Now, well, almost everybody's raising their hands. Everybody who didn't raise their hand, leave. Here's the deal. I said last year that with the energies that we're working with and the energies that are coming out that we are experiencing now, we need an entirely new set of technologies to be able to utilize them. We're not going to have the toasters that you plug into the wall and stuff like that. We will have those in the interim, but we need a new set of technologies. And this technology that you just saw a little bit of, and what I'm about to show you, is an entirely different way of thinking about power generation and power utilization. So what we're going to do is we're going to create a field of energy, a field of light and information that travels out and imbues itself, like I talked about earlier with the fractal imaging, imbues itself through implosion on everything else around it. So now we can go forward, please. That is what I want you to think about as you watch this video. And you can see all of this on his website, but it's not explained like this here. These are little pieces of steel with magnets on them, and they're all spinning at the same time. It takes 1 watt of power to turn the first one. And once the first one's turning, you can turn, I counted them out, there's like over 29 of them right here, okay? That's not 29% over unity, that's 29 times over unity, all right? Every single one of those can and has been hooked up to fans. They're hooked up to little power takeoff devices, but you're not going to get power by sticking a coil next to this like a Bedini motor or something like that. Got to think differently. Got to think in an entirely different mode of thinking in order to take power off of these little things. As soon as you start messing around with them, they start having interesting characteristics. Now, what's really fun is that these things can be any size, as long as they are perfectly matched with the original one that's turning. It's off on the side. You can't see it because we don't want to show how. I'm sorry. I just can't. But it's not one of these things that's going to be, it's going to be suppressed and put, no. This is going to be emerging technology in the next few years. We're not trying to revolutionize the world, destroy the oil industry, get rid of all power plants. We're not trying to do that because that's, I don't know, doesn't work that way. But you're going to see super efficient motors. You're going to see magnetic communication, because we've already played around with this. You can communicate through these things. Once you create that etheric field, you know, that little squiggly thing that I showed you, that field communicates to every single one that you put into it. And so if you put yourself into it, interesting things happen. If you put communication devices into it, interesting things happen. So we're going to be seeing this as emergent technology. We've already talked about Hartmut-Mueller and the global scaling. This applies itself to that idea. It's done differently, but that's okay. There's thousands of ways to do something. Every road leads to Rome. Okay, what's that? They're on top of little glass bowls. The interesting thing is, when we were doing magnetic motor research, we looked at the way most magnetic motors are designed, and they're designed all wrong. Because, let me ask you this, is there anything in nature that is perfectly spherical? Raise your hand if you can name one thing that's perfectly spherical, besides maybe a buckyball. Bubble. What? Bubble. Okay, all right. But is a bubble going to remain perfectly spherical all the time? No, it's moved by every little breath of wind that moves around, that pushes it around. Is there anything in nature that moves perfectly circular? No. You get out into space, every single orbit of every single planet is not circular, it's elliptical. Yes, and that we will be talking about that, because that is a transitional phase. We can put Mercury into a weightless space, and then it will freeze eventually, and that's basically a transitional state. We can do the same thing with metals. If they take and melt metal in space, this is some of the experiments that came out of Skylab. If you melt metal in space, in a vacuum, and allow it to solidify, you get ball bearings that have absolutely no friction whatsoever, because they have no tool marks, they have nothing there. Yes?
How about electrons in orbit around the nucleus?
Do electrons actually move around the nucleus?
Don't know for sure.
I know, that's the problem. Quantum physics says that, okay, our established idea that electrons, all right, let's call that Q, let's call that the nucleus, and electrons move in this is the model that we've all been taught. Electrons move in a circular orbit, and some of them are moving this way, and they move it in different ways and patterns and at different levels. But as Thorsten Ludwig said today with Heisenberg's idea, is that you can never predict where that electron is going to be. It might be there, or might be there, or might be there. There are only possibilities. So we don't really know what's going on inside that electron, but we use this model, and that gives us a certain perspective. Now, in my article for the Tesla Technology, or the magazine anyway, I said something very poignant. Something viewed from one perspective is by definition two-dimensional. Do we live in a two-dimensional world? No, we don't. We live in a 3 or 4 or 5-dimensional world, and so we have to look at things from many perspectives. Science is one perspective. Right here today is another perspective, so we're having fun with that.
So are you suggesting that magnetic motors need to be designed with elliptical paths?
We've already designed magnetic motors with elliptical paths. You send them down a long curve here, and whip them around, and they'll send down a long curve here, and whip them around and send down a long curve there. And we can, do magnetic trains all day long, because they're moving in a linear motion. When you put magnets, and I'm not saying it's not possible, because this year I have seen some things that I thought were not possible last year. But when you put magnets into a sphere, do I have a sphere? I don't have a sphere. If you put magnets into a circle in a circular pattern, it doesn't matter if you've got 4 magnets 20 feet apart or 100 magnets this far apart. They phase lock together, and they create different characteristics than the individual magnet. If magnets were a static thing, we could do amazing things with it, but they're not. Well, we could do certain things with it, but they're not. You put them together, and they lock together, and you can't use them the same way anymore. So they can take magnets and add them together, and it's the gestalt. The whole is greater than the sum of its parts. So yes, magnetic motors, circular, they're tough to make work. I'm not saying it's impossible. I've heard some people that have done it. I'd really like to see it, but we've been playing with the elliptical, and that's great. We've also been playing with linear. Forget why, we can do it steam engines. Push, pull, implosion, explosion, and that works great too. And I just heard about another one that uses the nature of magnetism that can move apart, and works on that principle as well. Don't limit yourself to one mode of thinking. We've got the two-dimensional perspective. who wants to live on a piece of paper. It doesn't work. So, moving right along, what is next anyway? I'm not moving forward. Okay, thanks. All right, thank you. We're going to move on a little bit right now and study about the true nature of electricity and implosion. Now, we've always been taught that in an electrical circuit you have a battery, and that is going to push electrons through the circuit over here, through the light bulb where it will generate light, lose a certain amount of power, and then come over here and drain the battery. Let's equalize the battery, okay? It's going to equalize it. We have a differential, push it over here, and suddenly we have an equalization, no more power. Well, quantum physics, conventional quantum physics, has now learned that this is a complete and utter fallacy. This has gotten us so far, and we have great flashlights, and we have laser LEDs, and we have stuff like that, but how do we get to the next level? We have to look at it from another perspective, and what quantum physics says is that there is a field, Tracy, around this circuit, a field that surrounds everywhere. Could I get some water? Water? No, water. Yeah, thank you. We have a field around this circuit, and when we put the battery, when we put the final components in line with that field, or excuse me, into a circuit, that energy then collapses into the circuit and manifests whatever the circuit is designed to do. So the field is out here all the time, and when we put that when we throw that switch, when we put that final component into place, the field then collapses and becomes whatever we want it to be. All right? So think about that. The applications for this are, when you think backwards, it's a little bit different. It's a little bit different. So we're not just generating light coming off of here. We're allowing the ether to flow in a pattern that allows the ether to manifest as light. Unfortunately, it also manifests as heat, which is loss. Well, is heat loss? No, it's a transitional phase of energy, differentials. All right? And to actually look at what those fields are doing in there, we look at this. This is a picture of the energy that is traveling through that wire. Now, one pole of energy will start at one end and move through that wire this way. Another pole of energy will start at the other end and move this way. And so, where's the ether here? The ether is manifest at these points. There is no DC. This is a battery voltage circuit, and it's alternating the entire time. Somebody mentioned last night that in a straight piece of wire they found that it had 0.06 microhenries, I think it was. 6 microhenries. Thank you. 6 microhenries of inductance in a single wire. But wait a minute. It's just a single wire. It's DC. It's traveling straight. We shouldn't have any henries. We shouldn't have any inductance at all, but we do, because the energy is moving in this pattern. This is why people, when you put excuse me, wires together in a motor or in a coil or something like that, and you start pumping energy through, you start getting heat and you start getting problems. And I figured out why it's doing that. I'll talk to you about it today, later tonight, because I remembered something that tells me why it's happening. What?
The circles and the green dots.
The circle. That's the. I'm sorry. That's an overlap. That's an artistic. That's an artistic play right there. That's my buddy John Depew. He's an artist, and yes, those circles are little curlicues, and they may actually be something, because nothing here is completely just for looks, but we don't know yet. This is a field of study that we're just barely scratching the surface on, but we're working as fast as we can. Now, this technology, or this idea applied to things like hydrogen generation, gives you a completely different perspective on what's happening there. So you get a hydrogen electrolyzer, and you get a plate here and a plate here and a plate here, and we're going to push a whole bunch of electricity through this. We're going to generate heat and stuff like that. But what if we were to place the plates right there? Excuse me, my hands are shaking. What if we were to place the plates right there on those 0 point spots? where the two energies mix is the space in between the plates, and you allow the etheric, you allow the etheric implosion to do its work, or you offset it so that the plates are here and the conjunction is there. What's going to happen? No, this is just straight DC. We don't, not being DC, this is just straight battery voltage. But using this technique, applied to some interesting things, we've got 180% efficiency on electrolysis using straight battery voltage. No frequencies, not needed. I mean, frequencies make it better, but that's okay, yes.
Is it possible to
He was first.
calculate the position of those nodes and antinodes on the...
Say again? Is it possible?
To calculate the position of the nodes and antinodes?
We are working on measuring the position. He asked, is it possible to calculate the position of the nodes and antinodes on an electrical wire? And the answer is, I don't know if I'm actually trying to calculate it. We're trying to measure it out. Okay? But yes, it is possible. And what's interesting is those nodes change by the amount of energy going through it, and the voltage and the current going through it. They stretch out, elongate, stuff like that. So,
okay, what techniques do you use to measure those? Because, for example, in a Brown's gas thing that's out there, they say we're driving this end, all kinds of plates in the middle that aren't driven, and that's striking a resonant chord with what I'm seeing there in the Coral Castle thing.
I will talk to you about that later. Okay. All right. Let's see, because we've got a lot. I've got a little bit more to go through here. Let's see. Yes.
If your work shed light on the John R. Searle technology.
The Searle disk, the magnetic levitating disk. Yes, it does, and it's my personal belief. Searle did some amazing work with magnetism and levitating disks and rotating magnets. It is my personal belief that we've seen levitation with magnetism already. We've seen gravity negation with magnetism already. If you combine it in certain patterns in certain ways, yes, I believe that you could lift it up. And I believe that he did it, but that later on he was using different types of magnets made with different machines, made in different locations, and every time you change the parameters, you change the magnetic fields. We're not just dealing with north and south, we're dealing with many different fields. So thank you. Yes. So it's my belief that it worked in the beginning at least, but then as the parameters changed, things changed from there. So where are we here? Okay, this is a graphic representation of what's happening in that wire. It's a two-dimensional representation, but you can see the counter-rotating spirals move through the wire. If you stack up a wire in a coil and it's too close together, you'll generate heat. It's not so much separating them out so you get air through it to dissipate the heat, it's that you're separating them out so they no longer interchange with the next layer above it. And I actually saw a Hieronymus device recently that was a multiple coiled, multiple layered device, and he knew this somehow. And he had his primary coil was a single wire that was straight that moved past the other coils, and that induced a field from those spikes into the rest of the coils, and that gave him some type of etheric energy that he was able to tie into the radionically. You know, we're not going to go into this because that's just too much to go into right now. This right here is a way that you can tie into and change the nature of the energy that's flowing in a circuit. It's a spark gap. And when you have a pointed spark gap, you have a different interaction of these fields of energy here, these fields of light and information that come off. When you have a square one, you have an entirely different reaction here. So if you're working with Tesla coils, you're working with radionics devices, anything that involves a spark gap, change the length, change the shape, change the material, and you will change the characteristics. Sonny Ward, he uses that deal and he can implode anything there. You use a different shaped electrode and you have different responses. So, moving right along. Now I talked about collapsing energy patterns. And, excuse me, these geometrical patterns here all do different things. And I'm not just talking about pyramid power. Isn't that a beautiful pyramid? I'd love to visit there someday. I'm not just talking about pyramid power, preserving things, preserving mummification, whatever. I'm talking about actual energy. Now, Tracy and I have a friend, a little guy named Kwaku. He said a pyramid, he figured that a pyramid was a means of controlling the energy, and he wanted to see what would happen if he just just let it free flow into something and see what happened. So he made a whole bunch of little cones and started applying high voltage electricity to it. And what happened was this beautiful blue DNA rope that came off of the top of the cone. Now everybody's seen the picture of the Tesla coil inside the pyramid, and you see the single thing going up in the Carillion photography. This didn't need Carillion photography. This was right there. It was energy coming off the top of the cone. So then Kwaku says, hey, wait a minute. Let's take two cones and put them together. We're going to insulate them here and join them together in a certain way using a certain type of energy and see what happens. And so then he takes he applied 13,000 volts from a flyback transformer on a television set to this, and that's how he saw the blue energy coming off of that. But what was interesting, he said he measured there, and it was 13,000 volts. He measured there, and it was 13,000 volts. But somehow, this focused that energy and saw the blue DNA rope coming off. So then, as I said, he said, let's put another one down here. Let's put another one on there. We're going to join it together, and we're going to input energy into it, and then we're going to put 13,000 volts there, and guess what happened? He sees a powerful, and this was insane, because when we saw this, it was scary. Powerful white light coming off of this thing. It was like a white, it was like an etheric light right there. It was white, and it was silent. It was very strange. But when the probe measured 13,000 volts, the probe moved up there, the probe shorted out and electrocuted him and crawled all over the insulation and right into his hands, and he had to jerk it away because it was drawing him in. Just from applying two cones and two neodymium magnets in the base. All right? What's that? That was yours. These were the ones that you saw. The blue one. The blue one. The blue one was covered with magnetite. This one was just a straight metallic cone. Two metallic cones. Yeah. But here's the deal. They have to be specifically shaped here. It's all fire harmonically tuned. If you just go out and build a 45-degree cone, not going to do it. It's got to be fire harmonically tuned.
Like capacitors that have an insulation?
What's that?
Are they kind of like capacitors? They have an insulation in between?
They are. They had a plexiglass insulation between the bases, and they were held together with magnetic fields. So moving right along, how much time do we have? 10 minutes? Is that what you said? Who wants me to stop? 1 minute. 1 minute. Okay, we got 1 minute. All right. We're going to warp time here. Implosion is the secret to alchemy. You can change the nature of reality using implosion. You can change the nature of reality using your hands in implosion. We've been working with this. It's an amazing field. You can change the nature of reality with implosion. These are Chladni patterns, cymatics patterns. All right? These are little Egyptian pictograms, and what's interesting here is you see these little wave patterns out here. I've seen other ones that look just like phonographs. I mean, they look literally like phonographs, and these snakes are coming out like sound would, and they've got these little cylinders at the bottom. Is it that much of a stretch to think that maybe the Egyptians had, like phonographic technology? It's really easy to do. I mean, it's not a stretch at all for me to think that. But then I started studying alchemy and noticed that these eggs had these same snakes, and I can show you the same thing in Egyptian petroglyphs. These eggs had the same shapes with the snake wrapped around it, the same snake that's coming out of there. And so I said, okay, well these patterns, these beautiful geometrical patterns created from frequencies come out of just vibrating sand or light with frequencies. So what would happen if you applied frequency to a egg structure? Now I said last year, remember what this is? This is the alchemist's anathor. This is how they changed lead into gold and different stuff to make people immortal, okay? What if you were able to play frequencies through that? Would you change the nature of the reality inside of that egg? Absolutely. And people have done this now. And a friend of mine was involved in an experiment, not exactly like this, but that used implosion and light, and he was able to make copper that didn't melt at 5,000 degrees and wasn't touched by nitric acid. And another person was doing the same thing from a different angle, and he was able to make silver that isn't dissolved by nitric acid and behaves more like platinum, but it still X-rays out as silver. So we're changing the nature of reality, and it's all done with implosion. So that would be really, really nice, and I'm looking forward to it. I haven't done it. So that would be great. That would be absolutely great.
Vernon?
All right, we're done there. We're done there.
How many minutes do you need to really do a good job of finishing up?
Well, I'm just about there. Okay, I'm not going to talk about implosion in the body. Just know that your bodies are etheric devices that gather the etheric energy and focus it in and change it and to utilize it, okay? You can change it with your hands, you can change it with your cellular structure. Tracy talked about Lyme's disease. She and I have had many discussions about how the different, what's that?
The trampoline, that's what you're saying, you're focusing the etheric energy on the trampoline.
You lost me there.
Oh, that was when you were sleeping through my talk.
Oh, that's right, yeah. Okay, your body's changed things inside of itself, and I've got papers I can show you out in the hall that literally show that your body utilizes etheric energy and changes the elements back and forth inside your body. And without it, okay, these are actually pictures of high voltage electrical streams. Get with me outside, and I will show you the exact same thing inside of your body, and it's a plosive reaction. So think about that as you go about your daily life, and about how you're tying in. Oh, and about the Lyme's disease, different diseases limit your body's ability to implode and alchemically change to what it needs to be. So we don't have time to go into that. I thought it was going to be much more. Anyway, any questions right now? We got one right here. Okay. Oh, I'm sorry.
I was curious if the motion of electrons along a conductor in the DC current had anything to do with the patterns.
Oh, absolutely, absolutely. If you want something to flow, do you call an electrician or do you call a plumber? All right? Electricity travels on the outside of the wire in those patterns that I showed on the screen, in two counter-rotating vortexes down the length of the wire, around the outside. Okay, next question. What's that? Is that it? Wow. All right. Oh, there's one.
We'll do one. We'll do one more. Who'd you recognize?
Gentleman right there. It's okay. Can you just shout it out? Oh, okay.
Oh yeah. I was just wondering if you could tell. You saw the recent organic machines that John Depew had made.
Use the mic.
I can't. You know what? Don't worry about. I can't talk about that. I'm sorry. I really am. I can't.
All right.
So don't worry about that.
Magnets, when you spun one, the others started by themselves, or I didn't quite understand.
When the mother, we call it the mothership, when the mothership is started up, spinning at a certain frequency, they all have a certain frequency, then you can start the next one, the next satellite spinning, and the next satellite spinning, and the next satellite spinning, and they are tying into that field that the first one generates. They're all tying together. And so you can put as many as you want to into that field, and they will all be phase locked together at that frequency, at that rotational pattern.
Power to one.
You put power to one, and the rest are spinning. So.
Is that magnetic field frequency?
Yes, it is magnetic frequency. It is magnetic frequency involved there. So, thank you very much. I hope I made some sense. Thanks a lot.
Thank you, Vernon Roth.
Thank you.
Okay, we're going to take a